Welcome! In this video, I'll show you how to turn real-world data into classroom-ready cartograms using only free no-code tools. By the end, you'll know how to fix geometry problems, join external data to map data, and export polished cartograms. Here's the classroom setup. Students receive two handouts. On the first, they estimate how many residents live in their neighborhood's planning areas, assuming the school is in northern Singapore. Without revealing the correct numbers yet, students then receive a second handout with cartograms showing planning areas scaled to populations. Students compare their earlier estimates with the values implied by the cartograms. The goal is to build data literacy and map reading skills, and to reflect on the advantages and disadvantages of different data visualization techniques. You can find the handouts and instructor guide at the links below this video. Although this scenario is specific to Singapore, the steps for making cartograms from scratch are broadly applicable. I won't assume any coding knowledge. We'll use only free tools: gocart.io, MapShaper, Google Sheets with a change case add-on, and an online SVG to PNG converter. Links are below this video. All you need is a Google account. First, a quick demonstration of gocart.io using an already cleaned dataset. 1. Click Create Map. 2. Upload your data, for example, a GeoJSON file. 3. Select the attribute that identifies regions, for example, region name. 4. Choose the visualization type, for example, a contiguous cartogram, and 5. Click Generate. You'll see a map view with both a conventional reference map and the cartogram. Real data aren't always clean enough to proceed that way. We'll work with two datasets from data.gov.sg, planning area boundaries in GeoJSON format and residents by planning area in CSV format. Links are below. When I upload the raw GeoJSON, gocart.io flags a topology error. To investigate the issue, I recommend MapShaper, an online tool for viewing and editing geospatial data. After uploading the GeoJSON and selecting the intersection display option, MapShaper reports one line intersection highlighted by a red point in the north. Zooming in reveals that two polygons overlap at that point, making the data unsuitable for cartograms. Let's fix this problem. Open MapShaper's console and run -clean, which repairs topology violations. Then export the map as a GeoJSON file with the -o flag, naming it sg_planning_areas_tmp.geojson. The _tmp suffix marks this file as temporary because we still have to perform additional steps before the data are ready for gocart.io. Another issue appears when uploading the temporary GeoJSON to gocart.io. Using name as region identifier won't match the population records from data.gov.sg. A string search in the population CSV reveals that the string KML doesn't occur there, so we can't merge the data using this attribute. Switching the identifier to description reveals a long HTML string. The good news is that description contains the planning area name, PLN_area_N, and a two-letter code, PLN_area_C. We just need to extract them. I use Google Sheets for this task. Unfortunately, Google Sheets can't import GeoJSON directly, so I download the information from gocart.io as CSV and upload that file instead. Gocart.io renamed the first column from description to region. Let's revert this change. Then duplicate the description column, rename the copy region name, and strip the HTML with a find and replace tool. I enable search using regular expressions so that I can use the .* wildcard. Replacing the search pattern with a blank removes all characters in front of the planning area name. Then replace open angle bracket /td close angle bracket .* with a blank to remove everything after it. Repeat the process to obtain the two-letter codes. First, copy all data cells in the first row to the third row, named Region Label. Then replace the regular expression with a blank. Download the sheet as CSV named sg_planning_areas.csv. We still need to clean the population data. Upload the CSV from data.gov.sg. The rows span multiple levels: Singapore as a whole, planning area totals, and subzones. Because we want planning area totals, I filter the first column for text ending with hyphen space total. Copy the filtered names and the total counts into a new sheet. Rename the columns as region name and population. Additionally, remove the hyphen space total suffix from the planning area names and, using the data menu, trim the white space to fix inconsistent spacing. Next, I uppercase the planning area names because they appear in that format in the spreadsheet we created earlier. Unfortunately, Google Sheets doesn't provide a built-in menu option for uppercasing, so I use the Change Case add-on, which is freely available from the Google Workspace Marketplace. I provide the link below this video. After Change Case is installed, uppercasing is available via the Extensions menu. Furthermore, I use Find and Replace to change every hyphen in the second column to 0. Finally, I name the document sg_residence_by_planning_area and save it as sg_residence_by_planning_area.csv. Now merge everything using MapShaper. Import the three files generated so far: sgplanningAreas.tmp.geojson, sgplanningAreas.csv, and sgResidence.by_planning_area.csv. In the drop-down menu, activate the polygon layer. In the console, join the planning area names and two-letter codes to the geospatial boundary layer. -join sgplanningAreas keys equals description, description. These are the region identifiers common to both files. Fields equals region name, region label. Using the Inspect Feature tool, confirm that both region name and region label have been added to the polygon data. At this point, we can drop redundant fields. -drop fields equals name, description. Inspecting the features proves that only the region name and region label attributes remain. We still need the population data, so I run -join sgResidence.by_planning_area keys equals region name, fields equals population. After confirming that the population has been added as attribute, I remove the CSV table layers by right-clicking, keeping only the polygons. Let's export the cleaned data using -o sg_planning_areas.geojson. Back in gocart.io, upload the final GeoJSON, set region name as identifier, choose contiguous for the cartogram, and click Generate. The result is geometrically correct, but fine-tuning is still needed. Ideally, neighboring planning areas should differ in color. Gocart.io adopts a corresponding 6-color scheme, but cartogram distortions can create new near-neighbors. In this example, the colors for Pongol, PG, Pasir Ris, PR, Bedok, BD, and River Valley, RV, are suboptimal. To tweak the colors, click Edit, select Custom from the Color drop-down menu, and use the browser's color picker to select from the existing palette. I make Pongol yellow, Pasir Ris orange, Bedok red, and River Valley yellow. You can also adjust or remove labels manually in the browser. Afterwards, generate the cartogram again. When you're satisfied, click the Download button and export as SVG, a vector image format. If you require a rasterized image format, such as PNG, use an online image conversion tool, for example, Vincent Rubinetti's web application. I recommend a moderately high raster size, around 2000 pixels on the long edge. The sample classroom activity also requires a non-contiguous cartogram. In gocart.io, click Edit, switch the visualization to non-contiguous, and generate the map. In summary, we sourced official boundaries and population data, fixed topology, extracted clean names and labels, joined populations, and exported both contiguous and non-contiguous cartograms, ready for classroom use. Student handouts, the instructor guide, data sources, and software links are below. Thanks for watching, and happy teaching with gocart.io.